Hello friends, this is Dr. Kamish here again. In this video lecture, I will discuss the basic concept of the Laplace transform. This concept was given by Pierre-Simon Laplace, and it has been widely used in different branches of sciences as well as engineering, also in philosophy. So first of all, let us know what is the concept Laplace transform. The Laplace transform is defined as if ft be a function of time t where t is greater than or equals to 0, this is the condition, then the Laplace transform of this function ft is defined as 0 to infinity integral 0 to infinity e raised to the power minus pt ft dt, provided that this integral exists. This is the condition. That means this integral will be a transform if it exists, where p is the parameter. It may be real or it may be complex. So to exist this definition, there are some conditions. First of all, the function fx must be of exponential order, and second one, function ft must be a piecewise continuous function. So what is the exponential order function? Exponential order that means mod of ft less than equal to some real number e raised to the power at. Again, a is any real number. So in first example, a very simple example, we can assume that e raised to the power at is an exponential order function. Why? Because we can write e raised to the power at less than equal to 1 e raised to the power some a1 t, where a1 is greater than a. So definitely this exponential function satisfying the condition of exponential order. Therefore the function is of exponential order. And the second condition is function is piecewise. We can understand this concept piecewise by this rough sketch. Suppose the whole function is the union of all such branches, this one, and this one. So this is a continuous function, but it has 1, 2, 3, 4 and 5 branches, and these are the pieces of the continuous function. Therefore this function is the piecewise continuous function. So these two conditions must be satisfied to exist the Laplace transform. There are some basic formulae. First one, the Laplace transform of 1 is 1 upon p. Laplace transform of t is 1 upon p square. Laplace transform of t per raised to the power n, where n is positive, factorial n upon p raised to the power n plus 1. T raised n Laplace transform of t raised to the power n, where n is not a positive integer, n may be any real number greater than minus 1. So then gamma n plus 1 upon p raised to the power n plus 1. Similarly, Laplace transform of e raised to the power at is 1 upon p minus a. And again another set of formulae, e raised to the power minus at has Laplace 1 upon p plus a, and Laplace transform of sin at is a upon p square plus a square. Similarly for cos at, p upon p square plus a square. Sin hyperbolic at, a upon p square minus a square. And in the last, cos hyperbolic at, p upon p square minus a square. So these are the some standard formulae, or we can say that these are the some standard functions whose Laplace transform are given here. So here now I will prove at least one formula of the Laplace transform. Suppose we are calculating the Laplace transform of e raised to the power at. So let us take the case of to find the Laplace transform of e raised to the power at. So what is the formula? Formula is 0 to infinity, 0 to infinity e raised to the power minus pt e raised to the power at dt equals to, we can write here 0 to infinity e raised to the power negative sign p minus a t dt, and the integration of e raised to the power negative p minus a t over negative sign p minus a 0 to infinity. And when we put the limit 1 upon p minus a can be taken as common, and when we put the limit infinity, then it becomes e raised to the power minus infinity, and when we put 0 then it is negative sign के साथ e raised to the power t, put t equals to 0, so it becomes 1. It's equal to e raised to the power e raised to the power minus infinity is 0, so 1 upon p minus a multiply minus 1, so the standard formula is 1 upon p minus a. Therefore the Laplace transform of e raised to the power at equals to 1 upon p minus a. Similarly all the formulas can be proved. Now consider one example. So example is to find the Laplace transform of 7 e raised to the power 2t plus 9 e raised to the power minus 2t plus 5 cos at plus 7t cube plus 5 sin 3t plus 2. And this example is the example which is reviving all the formulae. So Laplace transform of this expression is 7 can be taken as common, it can be taken out from the Laplace L. So we have to compute here Laplace transform of e raised to the power 2t, which is 1 upon p minus 2. Similarly Laplace transform of e raised to the power minus 2t is 1 upon p plus 2, and 5 is again taken out as common. So Laplace transform of cos t is p upon p square plus a square, here a is 1, and plus 7 t cube, 3 is integer, so factorial 3 upon p raised to the power n plus 1, that means 3 plus 1 4, plus 5 into Laplace transform of sin 3t a is here 3 upon p square plus 3 square, that means 9, and in the last Laplace transform of 1 is 1 upon p, and after simplifying this result can be obtained. That's all from my side. Thank you very much.